I have a question about coding languages as it pertains to AI, and it's not what you think. Because typically it's like, is AI good for coding? And that's
no.
No. And I figured you'd say no, and I would love to talk about that, but there's so much to talk about.
There's a lot of conversations about that already.
How much? I'm just gonna sort of put together a series of questions to get to a final question.
Yeah.
Because I was talking about this with my brother, and he and I were talking about something that Primogen said, and I think he's going to come on the podcast here. I don't know if you know Primogen, but
yeah, I've talked to him briefly before.
We were looking at some of his tweets, and we were thinking, how much of binary, how much of code, how much of the process of code, how much of it is weighted down? And by the way, I'm a layman, okay, so I'm trying to explain this, but how much of it is it weighted down by being wrapped in semantics that are readable? Does that make sense what I'm asking?
So yes. I would say, well, you can keep going.
So my question is, what's the point of a coding language? The point of a coding language is that it's readable to you and the computer. It's a way for you to communicate with the binary of the computer and with the human. Doesn't AI suddenly remove the need for languages?
It actually, so it doesn't, because, so do you mean a hypothetical interface where I just type into the AI
and it writes binary on the back end, but it spits out, it could spit out any other language you want. You could say, tell me what you just wrote in binary in C#, so that I can read it in C#, but what's actually being input into the game itself is binary, so that it's lightweight and there's nothing wrapping the code in something readable.
There's a bunch of reasons why that's not going to be true anytime soon. The first one is just, so we use language models for all this stuff right now. I don't think that that's the most promising form of AI for doing smart problem solving. Like I think the kind of stuff like AlphaZero, right? The program that learned to play games and from nothing. That's why it's called AlphaZero. That is not a language model. It does use some deep learning techniques, so it's related, but it's not trained by like throwing all the text on the internet at it, right? It's like it's trained by like playing itself at the game. I think if we have something that's good at programming eventually, it would be more based on something like AlphaZero, but then it would use a language model to talk to you, right?
Correct.
And so it would be a fusion of these things.
Okay.
The problem is just, there's a bunch of things. So using going back to LLMs for a second, like if you ask an LLM, please write me some JavaScript code to do a thing or whatever, right? It's going to give you back source code, which is in the programming language. So it's not doing the thing that you're talking about yet. I think you're talking about a hypothetical future.
A hypothetical where it's actually writing binary, but it's readable.
So the problem so far is like anytime it gives you that sample code, it's going to be using. So there's a thing called an API, right? Which is just, it's an interface to some code that somebody else made that already does some sub part of your problem, right? So like, let's say I want to make a 3D game. If somebody wrote some code that could draw an individual triangle for me, then I could use that many times to draw a bunch of triangles to put something on the screen, right? That's not actually how it works anymore, but that's an example. So the problem is those APIs also are only accessible through the interface of the programming language. So like, let's take C++ for a second, because that's closer to what you're talking about, where a C++ program is actually a binary on the disk, whereas JavaScript like is text and requires the browser to turn it into something every time it gets loaded, right? But so code that's in C++, it's not just pure binary that tells the computer what to do, because a lot of it is like how to interface with other C++ modules and other parts of the system and all that. And so, I mean, it would have to at least emulate all that stuff in the output binary, but if it did that, it would still sort of be that binary from that language until we got to some point where we're past that. I don't know. But I guess what I would say, here's the thing that I would say about all that is, if the computer is so smart that it can do the whole thing from one prompt, like make me a first person looter shooter, but the combat is like Tarkov, but not broken, and the net connections are good, and what you list out all the things you want, and it'll actually one shot it for you. if we ever get there, who knows, right? That's amazing. Yeah. So amazing that like none of us have jobs and all that, right? But the problem is if you can't one-shot it, how do you refine it? Okay, one thing is you try to play the game and it's not like the experience that you wanted. Why isn't it like the experience that you wanted? Well, it doesn't feel right. When I'm running and then I try to vault into the window, it feels sticky. And like, why is that? Why does it feel sticky and weird?
Yeah.
If you say to the AI, it feels sticky and weird, is it going to have any idea what you're talking about? Is it going to be able to fix it? Probably not. And so you need something that you can look at to figure out why it feels sticky and weird, even if you're not going to edit that. But like having some human readable code representation in the middle, you could at least say, hey, AI, I think in function, vault _ onto _ window, it's reading the wrong variable, or I don't understand why it's doing this. Can you at least explain it and fix it if it's whatever. So for the foreseeable future, that kind of programming is going to involve converging on something by steps. And you just would need a representation like that as the human to like understand what's going on at all, right?
That makes a lot of sense, man. Yeah, I don't think I have any other questions about that.
Okay.
It's
that's a long answer, sorry, but
no, it's great. It's great.
Sometimes.
The last podcast we did, some people in the comments were like, Thomas doesn't know how to keep up with John Blow. And I was like, yeah, that's true. You're on a different sort of level. I don't even know what
you can't, like,
I don't know what
the thing is, programming is so complicated. You can't expect someone who's not a professional programmer to like get it.
I can program C# from scratch. I know how to do all that, which is not impressive to you, I know.
But you don't spend most of your time doing that, right?
I did. I mean, I did for like a decade.
Okay, well, that's different.
And admittedly, you're going to hate me. Admittedly, I got Copilot running all day.
Well, that's fine. I mean, look, if
all day,
if that meets your needs,
it's weird.
Go for it.
That's what I'm struggling with, man. Is it does. Like I have knocked out, I kid you not, I've knocked out 1,000 feature requests and bugs from beta testers or play testers with Claude running on the side. And the reason why it works for me is because I've got my code base for Unity all done over 4 years, and it's written from the ground up custom with me and my team. Claude comes in, and what Claude does is Claude is like this. I'm not trying to sell you on it, I promise. I'm just trying to tell you this is my struggle, because I hear you say and I hear Prime say it sucks at coding, yet I've got it running and it's like solving all these problems. The game is still running 60 FPS plus. And I'm like, I'm sure it got a little bit more bloated, and I'm sure there's some junk in there, which would probably drive you crazy.
Well, I mean, what's an example of a bug that you fixed?
So let's say for some reason, Thomas can't figure out why playtesters are getting jittery movement on a gamepad, right? And so I can tell Claude, I can say, why is this happening? And it just scrubs through all of my controllers, my weapon controller, my camera controller, my character controller, the physics. It scrubs through all of it, almost like it's writing documentation. And then it goes, there it is. And it finds the bug. It's incredibly effective for me. And I'm not arguing with you. I'm trying to learn from you and figure out, what am I doing wrong here? It's really good at finding bugs, which on the tail end of development, this is what takes so long for me when I'm playtesting and there's 1,000 bugs to try and you don't even have to replicate them. You could just tell Claude, this is happening. Why is it happening?
Yeah. I mean, I think this is one of those things where there's a wide spectrum in programming, right? So one of the things that you'll hear say, one of the truisms is like, oh, in programming, you actually spend 95% of the time debugging or something. For me, that's actually not true, but it's because I've got a lot of experience. Mm-hmm. And because now I work within a system that, when you're in your own programming language, especially, like you wrote all the common code that gets, you're just very familiar with it. And when something goes wrong, there's this way that you can just be like, oh, I bet I know, right? And I've done this on stream before. I'm just like, oh, I bet that's this thing. And you go, and it is that thing, right? But okay, so getting back to the question, I think that there's different kinds of bugs. And what I would expect is that LLMs do better at some of the kinds of bugs than others. And maybe it's that a lot of your bugs are in this one category. And so the kinds of bugs are, let me call them, I mean, I want to say like shallow state versus deep state bugs, but that sounds like I'm talking about the federal government or something. But the point being, like, okay, whatever this gamepad bug is that you're talking about, it's like maybe the input was an integer and it was being cast to a float too late or something. Who knows? Who knows what it actually was? But that's an example of the kind of thing that could cause jittery motion. That's an example where the code is just kind of doing the wrong thing like all the time. And you can tell that it's wrong by looking at the source code, right? Hopefully, like if you're perceptive. Yeah. And I'm actually surprised from that description that this is an example of something that it found, but let's take that for granted. Most of the bugs that I find that are time consuming and difficult to solve are what I would call, I mean, again, I just said deep state bugs, but like things that involve state of the game that's kind of complicated. Also with the compiler, like state of the compiler, like we're compiling some sub-phrase of the programming language that has all these nodes and all these particular places. They're all pointing at each other and whatever, right?
Yeah.
Diagnosing those bugs is time consuming because the thing that's going wrong is kind of driven by the data being wrong, or the data is in a format, even though the data is right, it's in a format that is causing some combination of code paths to run that like isn't what happens in the general case. Those to me tend to be the problems. And those seem to hit the spot where LLMs are bad at. So my experience with language models is, and I think, so a lot of people's experience with language models, which I agree with, is let's say you're just starting and you're like, make me a web page with some buttons on it that does this or that. It'll do that, right? And it'll probably kind of mostly work, and you can fix up what doesn't work, right?
Yeah.
But the thing about a program is, as a program gets bigger and more complicated, then the process of programming, the process of modifying that code and adding new code is about making, like, the new lines of code that you make have to agree with everything that's there in the following way. Like, let's go back to entities or something, right? And this is a simple example. Like, the way that we do the coordinate system in this game is it's like 1 unit. Okay, grid-based game, like Order of the Sinking Star. It's 1 unit per square. The origin's somewhere near the corner of the level, right? Whatever. And so, and there's a gameplay position that's floating point coordinates, but they happen to be rounded to integers, but they're still floating point to make math easy. And then there's like a visual position, which is a thing interpolating around between the squares, right? But because it's a grid-based logic game, you don't use the visual position when you want to know if you are colliding with something or whatever. You use the gameplay position. So these are decisions that are made early on.
Yeah.
And so any further code that you make has to understand those decisions and interoperate correctly with them, right? And the problem, even before you talk about LLMs, just one of the core problems of programming is that as a program gets bigger and bigger, there's just more and more of those things that you have to keep straight in order to successfully edit the program. And if you don't, the result is bugs, right? One class of bug. And so as a program gets bigger and more complicated, there's like this really intricate like webbing. You could imagine a big messy spider web connecting all these little pieces where if this piece has to agree with this piece about how something works, there's like a really thin line. And software engineering is about trying to keep that from getting too messy, but like it's only possible to do so much. And part of the magic of games, part of the reason games are fun is because stuff in the game all interacts with each other, right? And that just means it's this system where things mix together. And so at some point when programming becomes hard, it's because both the number of these little spiderweb rules that you have to track in order to add new things to the code becomes very, very hard to keep up with. And then also, the more code there is, the more of this internal state there is representing the objects and all that. Yep. And that becomes more and more complicated. And the more complicated it is, the easier it is for that to be wrong. Now, the thing that I find about LLMs is just that they can't track all those. I don't think I said the word constraints yet, but that's how I think about it. There are constraints that edits to code need to follow in order to be correct. And at some point very quickly, you can start asking, I usually use, I don't know, I've tried a few different things, but whatever LLM, you say, hey, please add a function to do this, and it adds a function, and you're like, okay, you did that, but we need to also do this and that because of these constraints with other systems. And like, it might kind of do what you say, but it's not necessarily that good at really holding those constraints. And then it'll also start forgetting the old, because it's hard to do all these things at once.
Yes.
That's what makes programming hard. And it'll start dropping the old ones. And like at some point you just can't get it to do, because it's not, I mean, like I said, it's a language model, right? It's not like, it's not a chess player. And so what you really need is a chess playing AI. And that's not what we have.
We don't have that
to
yet.
program successfully. Now, again, so whenever you make this kind of statement about AI, everyone wants to turn it into like some extreme stance, like, oh, you're very anti-AI. Yeah. I'm not doing any of that. I'm not anti-AI. I think to the degree that it's useful, you should be happy to use it. I do, however, get irritated at what I perceive as the excessive claims made by a lot of people about what it does. Now, that said, you're also sitting here telling me you have a lot of success with it. So I don't know. I mean, maybe there's just something about your code base that makes it more attractive.
I don't know, man. I think I just need
to launch the game, right?
I know, yeah. I mean, my game is admittedly very heavy. It struggles where it shouldn't struggle, because it looks like a AA game from 2009. I mean, that's like the best case.
But that's hard. That's independent of anything, right? Oh, you mean just for the amount of geometry on the screen, you wish it were faster?
No, I think the geometry isn't even the problem. You know what the problem is? The problem is lighting. Unity's lighting is horrible. It's because by default, every mesh casts a shadow. And by default, every light casts a shadow. So if you're not an experienced developer and you don't know that shadow renders cause such a problem.
Yeah. So you put a lot of shadow casting point lights in the scene, and it
you're not realizing that a point light is 4 spotlights, that kind of stuff. Whereas when you build your own engine, I'm sure you have to think about all this stuff. And
so the programmers realize that stuff, but then you give this stuff to the art team and they just do whatever they want with it, right?